This is a project of a century.
The most impressive power generation system ever envisioned.
It's the hydropower equivalent of a mission to Mars.
For most of human history, water has been the main reason to fight. Rivers have decided where civilizations rise, where borders are drawn, and who survives when conflict breaks out. From ancient empires to modern nation-states, controlling water has always meant controlling life. And today, in 2025, one river flowing out of the Himalayas is quietly turning into a pressure point that could shape global politics for generations. For years, the Three Gorges Dam was seen as the peak of human ambition, a masterpiece of engineering, but also a warning about the costs that come with projects on that scale. Now China is moving far beyond that. What's being built today changes the conversation entirely. This is a project that has the potential to reshape energy systems, shift geopolitical power, and leave a permanent mark on the planet itself. In July 2025, something big changed. This project officially crossed the line from idea to reality. Bulldozers and cranes moved into the Yarlung-Zangbo Gorge. Roads were widened, and crews started digging in one of the toughest construction zones on Earth: steep slopes, thin air, earthquakes, and brutal weather. Just beginning work there was a message in itself. We're serious, and we can do this. What really matters is the commitment behind them. You can talk about building a massive dam for years, but nothing is set in stone until concrete starts going in the ground. Once tunnels are bored and foundations are laid, a project stops being theoretical and becomes inevitable. That's exactly what happened in mid-2025. China kicked off the early civil works every mega dam needs first: cutting diversion tunnels, stabilizing rock, and getting ready to control the river. These early stages are slow, risky, and expensive, the parts no one starts unless the political will and funding are already locked in. That's why this moment drew attention not just from politicians, but from engineers too. From July onward, this wasn't a future possibility anymore. It was an active build, a huge commitment with consequences that will play out for decades. The number everyone keeps repeating is 60 gigawatts. It sounds impressive, but most people don't really pause to understand how big that actually is. It's almost 3 times the capacity of the Three Gorges Dam, which is already the largest hydropower station operating in the world. Put simply, 60 gigawatts is enough to supply electricity to tens of millions of homes, while also feeding factories, high-speed rail networks, and other energy-hungry infrastructure, all at the same time. And unlike solar or wind, hydropower doesn't switch off when the weather changes. It provides steady, controllable power day and night. Here's another way to see the scale. Many countries don't produce 60 gigawatts from all their power plants combined. This single project is comparable to the entire electricity capacity of several nations. That's why attention didn't just come from politicians. Engineers, economists, and energy planners noticed immediately. When energy is built at this level, it changes what industries can exist, how secure a region's power supply is, and how much long-term influence that energy gives its owner. Not for years, but for generations. The Yarlung-Zangbo Gorge is one of the hardest places on Earth to build anything. It sits at extreme altitude, cuts through steep terrain, and lies in an active seismic zone where landslides and earthquakes are real risks. The river itself runs through deep gorges, surrounded by cliffs that rise hundreds of meters, while weather conditions can shift fast enough to halt work with little warning. Right now, the focus is on diversion tunnels, temporary channels that redirect the river so engineers can safely prepare the foundation. At the same time, crews are stabilizing enormous rock faces and carving access roads into areas that were previously unreachable. Every move has to be calculated. One mistake here doesn't mean a minor setback. It can push timelines back by months, or even years. The scale of what's happening on the ground is hard to overstate. It's closer to a moving engineering city. Cranes, tunneling systems, heavy machinery, and rotating crews operate around the clock in terrain that was once untouched. The fact that work began in July and continued steadily through December 2025 speaks volumes about both the technical capability involved and the seriousness of the commitment behind it. But the Yarlung-Zangbo doesn't end in Tibet. Downstream, it becomes the Brahmaputra River, flowing directly into India and Bangladesh. Along that path, tens of millions of people rely on it every day for drinking water, irrigation, fisheries, and electricity. When a river like this is controlled at its source, it creates leverage over a lifeline that stretches far beyond national borders. This isn't a theoretical concern. Hydrologists and regional experts have long warned that upstream changes can alter water flow downstream, affecting crop productivity, water availability, and flood behavior hundreds of kilometers away. The Brahmaputra Basin already faces seasonal extremes, swinging between destructive floods and damaging droughts. A project of this scale doesn't just produce power, it reshapes how water moves through an entire region, forcing governments and communities to adapt whether they're ready or not. From an engineering standpoint, managing a river this powerful is extraordinarily complex. China is installing systems designed to regulate water releases carefully, but on a river like this, even small miscalculations upstream can trigger immediate downstream effects. That's why the stakes go far beyond electricity generation. This is also about regional stability, influence, and long-term risk management. In the end, the impact of these dam effects will unfold over decades, crossing borders and affecting communities that had no say in the decision. Estimates place the cost at over $150 billion, putting this among the most expensive infrastructure projects ever attempted. That figure alone is larger than the entire GDP of some countries. It represents years of financing, long-term contracts, massive material flows, and tens of thousands of workers, all coordinated at a level only a handful of projects in history have reached. The timeline matters just as much as the price tag. Construction began in July 2025, but the project is expected to run well into the late 2020s, with full operation projected for the early 2030s. That means the choices being made right now, where tunnels are cut, how foundations are set, are commitments designed to last half a century or more. Large dams don't operate on political cycles. Engineers and planners typically design them for 50 to 100 years of service, sometimes longer. So while governments change, the physical and strategic consequences remain. What's being locked in today will outlive the officials who approved it and shape the region long after they're gone. That mix of cost, time, and permanence is rare. It's what turns the Medoc Dam from a construction project into a long-term force in energy, industry, and regional influence. Every section built today quietly reshapes the political and economic landscape for generations to come. What truly sets the Medoc Dam apart is not just its size, but the long-term impact it will have on the environment and the region around it. The Yarlung Zangbo Gorge is an ecologically sensitive area, home to rare forests, diverse wildlife, and river systems that have evolved over thousands of years. Changing the river's flow, diverting water, and creating a massive reservoir will permanently alter this landscape, affecting habitats, sediment movement, and ecosystems far downstream. The effects don't stop with nature. There's also a clear strategic dimension. By controlling the river at its source, China gains influence over water timing and availability for India and Bangladesh downstream. This is what makes the project unprecedented. It combines large-scale environmental transformation with long-term geopolitical leverage. The full consequences won't appear overnight, but the choices being made now are setting conditions that will shape both natural systems and regional relationships for generations to come. The Medoc Dam is ultimately about how a single project can rewrite the story of an entire region. Even before it's completed, engineers, policymakers, and researchers are already treating it as a case study in large-scale human ambition. From building in extreme terrain to managing one of Asia's most powerful river systems, the lessons learned here are likely to influence how future mega-dams are planned and built around the world. It's also reshaping how governments think about infrastructure and power. Across Asia and beyond, decision-makers are watching closely, because projects like this don't just produce electricity. They quietly affect negotiations, water-sharing arrangements, and long-term regional planning in ways that aren't always visible at first. There's also a human side that rarely gets attention. Thousands of workers, engineers, and nearby communities are part of a process unfolding across mountains, forests, and cultures. Their daily work, adapting to altitude, terrain, and isolation, is as central to this project as concrete and steel. When history looks back, the Medog Dam won't be judged only by how much power it generates. It will be remembered as a project that pushed the limits of engineering, reshaped a region, and subtly altered the balance of power, long before its full impact was ever understood.